areas in the plane. It's when you have like the two different functions like on the graph that you're given. You have like f of x minus g of x. So it's either like the top one minus the bottom one, or like the right one minus the left one. I think was the situation that we had in number 4. Something like that. Yes, that is what we had. So, number 6. So again, you might want your books open to page 399 to actually be able to see it. This one's a little different because of, well, just the way that it looks. But we've got the two functions. The top function, so 399. Y equals f of x is going to be equal to x squared. Y equals g of x is going to be equal to negative 2x to the 4th. And our interval for this one is a little different because it's got like lines going down it. So it's got like, they're like pink lines like showing you where it is or whatever, but it's going to go from negative 1 to 1.
Parallel line.
Well, they're pink in the picture, which is why I said pink lines. But yes, they are parallel.
Yeah, just making sure we're looking at the same thing.
Yes.
Number 6.
Yeah. I can't confirm it's the same.
All right, so we've got the integral from negative 1 to 1 of x squared. Now it would be minus, but this is a negative, so it's going to be plus 2x to the 4th dx so integrate that. What do I get? What was that?
He was about to sneeze.
I thought he was answering, and I was like, what in the world just happened?
Oh, goodness.
You had the 2 wait.
Integrate.
Yeah, I know.
You could break it apart.
Oh, wait.
Yeah, well, I mean, I can, or I can just leave it together either
Yeah,
way.
2/3 x cubed. I mean, disregard.
No.
1/3 x cubed.
1/3 x cubed.
Oh, yeah, because you could take them apart.
Wait,
Or something.
what do you mean by taking?
Oh,
Like,
wait.
I could have written this as two
Yeah.
separate integrals, as the integral from negative 1 to 1 of x squared dx
plus
plus
the-
the integral from negative 1 to
okay,
1
okay.
of 2x.
But you don't have
But
to.
you don't have to.
Correct. The reason I did on
Is it easier to plug in the...
this one was because I was dealing with, like, two entirely separate functions.
Yeah.
So it was just easier to deal with by separating it. But I didn't have to separate this one. I just did to make life a little easier. So, like, you can for this one, but it really is just going to be more writing, to be honest.
The second would be
2/5 x to the 5th.
And we're evaluating from negative 1 to 1. So when I plug in 1, what do I get?
You get a 1/3 plus 2/5 is what you would get.
Now what?
You want to get that common denominator.
Oh, I'm not done.
you gotta get the other.
Oh, so minus
Minus negative 1.
negative 1/3. Yeah, minus. Yeah.
Wait, what?
Shouldn't it just be minus 2/5?
Yeah, that's why I was like, wait a second. I thought that's what I had written, and then I was like, wait a second. They said positive. I was like, wait, no, that's not right.
So now you want to get the common denominator?
Well, I'm first going to see if anything can cancel before I do that.
Nothing can.
But I'm still going to rewrite this as like a simplified. So like 2/3 plus 4/5 And then now I would get a common denominator of what?
Uh, 15.
Well, okay, so the top is 10 plus 12. So
Yeah. What in the? Just disappeared. What is next?
That's nice. I'm home to see it.
All right, number 8. These ones say to use your calculator, so you're gonna want to have that handy.
She said she got a child with her. Like with another class.
What?
We're talking about brand vocabulary.
My class did that.
Were you the last class to do that?
We were the only class to do it.
She told us it didn't work.
Well, it doesn't. That's why
Pen said we could do that.
it doesn't work. Like it, because have you ever seen the thing when people will be like, they'll be like, oh, my house caught on fire, but like my Bible survived? Have you ever seen that?
No.
I see.
Fire
I heard
consumes
stuff like that.
all.
So yes, but no. So when you have like books like that have like all the pages together, it will only burn like the outer layers.
So we should just rip the pages out and toss them.
Basically, that's what you have to do. You have to like rip the book in pieces for it to work.
I'm still gay.
We did it in the back parking lot, but nobody knows that.
Not even the law.
Correct. My dad like brought a fire pit from home for us to do it. Yeah.
So you were the only class?
Yes. Because it was really, really shady
Yeah.
to begin with. I mean, it kind of worked, but it also kind of didn't. Because, like, it only really burns, like, the cover and then, like, some of the outer pages. Because we, like, threw them all in and then lit the fire, but it doesn't really... That's, like, also why, like, if you're going to, like, burn papers and stuff, you can't throw it in as a stack. You have to, like, crumple up the pages and throw them, like, each in individually.
I didn't know that. I'll know that next time.
I'll know that when we burn them.
It was fun. I mean...
Do you like playing with fire?
Oh, okay.
He's definitely gonna become an arsonist when he grows up.
What?
I don't know.
I'd like having bonfires. Like, is that what you're asking? Like, no, I don't play with fire. Like, I don't even light matches. Like, they freak me out.
Really?
Yeah, that's what lighters were invented for.
Jewelry.
No.
Put him in the thing.
Really, when was last year for how people become arsonists?
But that was so fun.
Yeah, we had an arson chapter. And we built those houses and burned them down. That was fun. We made little meat people.
I made meat animals.
It's very funny.
All right, so what we need to do is we need to put each of these graphs into y equals.
Now what?
Zoom 6.
Well,
Oh, it's like spinning.
Alright, so I want to zoom box this area here. Zoom box.
I think it's number 1.
Zoom
Zoom
one.
1.
What area? Just the middle?
Huh?
Just like the middle?
Yeah, really, just this area here, because we're trying to look at the enclosed region, which is going to be in here. Arrow over, hit enter, arrow up, and then arrow to the right, and then hit enter again, once it's the region you're looking for.
Oh, what do you mean error?
I got an error.
I don't
I
know.
don't-
It told me error.
Oh, never mind.
I didn't go-
I know how to do it.
Mine's
Hey,
a
you're
little
only
farther
hitting
out.
enter.
Is-
That's
You're only
fine.
hitting
Oh, I
enter
see.
twice.
We're trying to see this area in here.
Thank you.
Okay.
How can nobody tell me it's this? Look.
Does it now look like this?
Yeah.
Kinda.
More or less, like,
More or less like this, yes.
okay. So now, which function is on top?
The cosine.
Okay, so this is going to be the first one.
Oh, that's how you determine.
This is going to be f of x. Yes, and this is going to be g of x.
I can't
Oh.
read it. It's like really exposed.
So now,
Wait, but technically, why isn't it y equals x squared minus 2? Because like that part is higher than the.
but it's not. This is cosine right here.
Yeah, but like the
And
parabola.
this is the x squared minus 2. I don't care about anything aside from that.
Oh, okay.
I'm finding the area of the
I think I know what he's
enclosed
trying to say.
region.
Okay.
Now, I need to know what this enclosed region is. I need to know what this value here is. So I'm going to use second trace, I think. I think it might be intersect. Let me check.
I was definitely just guessing.
Yes, it is. Okay.
So what is it?
So hit second, trace, and then it's intersect. So option 5. So you'll arrow until it's on the one graph. Right? So notice how it's like on my cosine graph right now. You can have it on the other one first, doesn't matter. Hit enter. That's your first curve. Then it asks for the second curve, and mine automatically jumps to the other curve, like to the other graph. Hit enter. Guess. Hit enter. And it's going to tell you that that intersection point is at negative 1.153-ish.
Wait. Second trace
Intersect.
arrow over to.
You just need it to be somewhere on graph 1 and then another one on graph 2 when it does the second one. But if you do it on this side, it's going to become positive of whatever that value is.
I hit enter again to guess.
Yes.
And
And then I'm going to do it again just to verify. The number should be the same as the negative. It should just be the positive one, but just to make sure that like it wasn't shifted weird or something.
Is that like gonna be the interval?
Yes. So then second trace, intersect. But you need to go like over to like the right hand side of the graph now so that it'll actually pick this one. Like I'm trying to get it over here. So that one, intersect.
Oh, like on the inside.
wait.
Wait.
Like, I went to this side of the y-axis to select my graphs, because the other one, it was on this side, and that's why it's going to give me the negative intersection point.
Does it matter which side of the y-axis?
Yeah. Because if you're over here, it's going to give you this negative value. If I'm on this side, it's going to give me the positive one.
Oh,
Oh, no,
my
I
question
mean,
was,
if you're
as long
like-
as you're
if
on
you're
the
on the
right
outside.
side, as long as you're on the right side of the y-axis, does it matter?
No. You said,
Okay.
does it matter what side of the y-axis am I on?
Yeah, I'm sorry. I meant like.
So I was like, yes, it
Right.
does. The x-axis part, no. That one doesn't make a difference.
Oh, okay. Yeah.
So it does happen to be the same number. More often than not, that's going to be the case, but always good to check. I mean, this one looks pretty symmetric as it is, but. So now we're going to use those values to set up our integral. So it is going to be the integral from negative 1.153 to 1.153 of the cosine of 2x minus x squared minus 2 dx. Any guesses as to what I'm going to do about this situation? Well, I can split it. I can distribute, but is there an easier way I could do this?
Factor.
Yay!
What'd you say?
With a calculator. This is a calculator problem.
Okay, so this will be a calculator.
Yes.
Tell us that.
Amazing. Yeah.
The instructions do tell you that, yes.
And I mean, if it's on the calculator section, then it kind
If an integral's on the calculator section, I would plug it in.
of, I would. Yeah.
Even if it's on the short answer part where you're filling it in, I would say write it out and show how you get it, but then check it on your calculator if it's on the calculator portion.
Yeah, when's this AP exam again?
The 13th.
Yeah. No, that's the point. First place is the one. First place.
Oh,
the
the
one.
I swear I don't know the reference of it. You should.
Yeah. I know.
I don't know if I was, but that's kept you in mind.
Because that hasn't gotten to YouTube shorts yet.
Like, if you ever ask my dad how, like, a game went and, like, we didn't win, he'll say we came in second. And a lot of people don't register, like, that means you lost.
You lost.
It's just a better way.
He'll be like, how'd we do? And then, like, or somebody will be like, how'd we do? And then my dad will be like, we came in second. And the other people are like, that's awesome. And then he's like,
Yeah, it is awesome.
Yeah.
you didn't get it, did you?
Great.
He'll be like, it was a basketball game. There were two teams.
Oh.
Like,
One time I went to like
One time it's gonna be like, we got third.
after a soccer game when I was in my soccer uniform, and I think we just finished playing like HRA, and we like lost that game 1-13.
Hey, you got one though.
And like the workout chick was like, "Oh, how'd you do at your game?" And I said we won.
You lied.
I did lie.
You know what? I always say that too.
I
when
wasn't
we're
gonna say
doing
we lost 13-1.
Well, you didn't have to say you lost 13.
I mean, maybe it would have given you free food if you lost. Because you feel bad for you.
You could have said like you lost.
just be like, we did our best.
Yeah.
That's always a good answer. All right. The calculators do need to stay out because the rest of the problems, they don't give you the graph.
Oh,
You have to do that yourself.
that's not that
They're
bad.
asking too much of us.
So 16, they give us
These problems are
y equals 2x minus x squared and y equals negative 3. Now, if this was on a no calculator portion, do you think you can do this?
No.
We probably have to.
Oh.
What is this?
A function, an equation,
Use
Of what?
of a parabola,
Okay, and what is this?
a
That's just
Number.
a point.
straight line.
Okay.
Oh, that's true.
Oh, I guess we could do it.
So-
ooh-wee.
I think I know.
But would you still have to find intervals yourself, or you just add plus C?
You'll be able to see the intervals.
What is?
You'll be able to see it.
Okay. Being suffer, like, what is the like basic formula of a parabola? Is it just x minus x squared?
It's just
No,
X
it would
squared.
be
It'd just
it would be ax squared plus bx plus c.
Okay.
To find the vertex, it would be, or well, the axis of symmetry is at minus b over 2a.
Right.
I forgot all that.
Yeah, minus b over 2a.
Do we need to know that for the AP here?
I mean, possibly.
I think I'm just like every time you point to a function, you're like, what is this? And it's a parabola. I never know
I
that
know,
it's a
I
parabola.
think, and that's like the only thing I do know.
So the vertex point, the x value of it is this. The y value is f of whatever that is. So like when we plug that number back into the equation, what we get.
Okay.
So for this one, let me put some tick marks on here first. Which way does this parabola open, up or down?
Down.
Why?
Because it's negative.
Negative x squared.
Okay, so this is reflected, so it's going to open down. So my vertex, or my axis of symmetry, minus 2. What was that?
That was a paper.
Interesting. Over 2 times negative 1.
Oh, so we do need that.
So that ends up being 1. Right? Negative 2 over negative 2.
Oh,
Yeah.
are you showing us how to do it back again? But we can use our calculator.
Well, there might be one that we.
I mean, just in case it's on a no calculator portion, I think it would be wise to know how to graph a parabola, considering that was all the way back from like some of it in Algebra 1.
Right.
So
It's one of those things you like don't use. That's the problem.
that's why I'm like, this might be a good point to like,
Yeah.
review a little bit.
I feel like this was like geometry.
Probably not, but maybe.
Pre-calc. Wait.
We definitely did it in Algebra 2.
Algebra 2,
There was a whole chapter on it.
I just think the not using graphs that much is catching up to us at this point.
Then the vertex would be at 1, and we have to find the other point, so plug in 1. So we get 2 times 1 minus 1 squared is 1. So I have a vertex at 1, 1. Now, does anybody remember how to find another point on the graph?
Find slope.
No.
Wait, how'd you get the x value of 1?
The axis of symmetry is the point at which the parabola revolves around. So if you know what happens on one side of the axis of symmetry, you know that equal distance on the other side, the same thing happens. So any idea how to find another value? There's no special formula. It's easy.
Right.
Wait, like how to find another point? You would just plug that in to that. You find your
Plug
x.
that. What's that?
So pick an x value. and
Okay.
Plug it in as x, and that would give you the y.
What would be a smart x value to choose in this case?
0.
Yes. Why?
It's easy math. 'Cause anything
Easy math. Because if I plug in 0 for x, what do I get?
0.
0. So that means 1 away on both sides. I have that. Now, in this particular case, this is normally where we would have stopped. We would have drawn our parabola when we were doing them. Because y is negative 3, what is that graph going to look like? Where? Yes. -1, -2, -3. So I have a straight line through here. it would probably be wise for me to try to figure out what x value gives me something down here. So I might even plug in like -2 and see if it puts it down here so I know exactly where it's intersecting at. Okay? So, because normally, like, what would have happened, don't draw this yet, is I would have just done something like this and made an assumption that it looked like that. Right? Like, approximately. But because this is more specific, I need to probably find another point. So let's test, like, -2. So if I plug in -2, what do I get?
You said -2, so 2 times -2 would be -4 minus -2
Negative-
squared is
-8, yeah. Okay, so that's going to be really far down here, so let's try 1 instead. So let's try -1. What do I get when I plug in -1?
-1. Wait, -3.
So at -1, it's at -3, which means that I'm 2 away here, and it's there, so 2 away here, it's also there, and that way this works out nice and easy. So now I know what these points are, so I can use these x values as my parameters. So when I do this is going to be f of x because it's the graph on top. This is going to be g of x. And the parameters that I'm working with are from -1 to 3. Now, if you have your calculator on this problem, I would 100% use your calculator.
Is it -1 to 3 or 1 to -3?
-1 to 3. Yeah. Because I'm trying to find this area in here. That's what I'm trying to find. So, integral from -1 to 3 of 2x minus x squared minus a -3, so that's +3 dx. How do I integrate that? And before you ask, yes, you can split it. No, you don't need to.
Okay, so x squared minus 1/3 x cubed plus 3x.
Yep, evaluated from -1 to 3. So if I plug in 3, I'm going to get 9 minus 27 over 3. So 9 minus 9 plus 9 minus, plug in -1, that's going to be 1 plus 1/3 minus 3 so what is that, -2, was that -1 2/3?
Oh, you're distributing.
9 plus 1 2/3 or something like that, right?
Isn't it?
1 minus 3 is -2 plus 1/3,
Yeah.
so -1 2/3, right? Not like I'm asking, like, make sure, like, check me on that. So that would be 10 2/3, which would be 32 over 3. So on an easy one like this, okay, maybe you don't think it was easy, but on an easy one like this, you can do it by hand if it's on the by hand section, right, where you don't have a calculator. Stuff like graphing a parabola and things like that are things that they would just expect you to already know. They would consider this as a prereq for this class, that you know how to do this. So that's why it would be like that. And if all else fails and there's something that you have to graph and you have no idea what it looks like, no idea how to graph it, just start plugging in x values. Plug in x values starting at 0 and see what happens. Like make a table and just be like, all right, if I plug in 0 for x, what do I get? Plugged in 0 and I got 0. So, okay, I have a point at 0. Be like, okay, let me try 1. So I plug in a point at 1. I plug in 1, I get 2 minus 1, so that's 1. So at 1, 1, I have a point. And eventually, you're going to be able to graph what you're trying to graph. So you could graph a cubic function the same way, right? You just need to get it to know, remember back to the 12 basic functions from pre-cal of what, in theory, should this look like.
What are the 12 basic functions? That's a serious question.
Like y equals x, y equals x squared, y equals
Was that
x
what y'all were
cubed,
thinking?
Yes.
y equals sine x, y equals cosine x.
Yeah.
I think e to the x was one of them. I think ln of x was one of them.
What is it called? The 12 basic functions?
There's probably a video out there of it if you need to go back and look them up.
You're saying your notes?
I just need like a Schoolhouse Rock song and then I'll be able to answer it.
I highly doubt that's a Schoolhouse Rock song, but maybe it is. I don't know.
Ah, no, I remember this.
Good.
Okay, well, that's good. All right, 18. Y equals x to the 4th minus 4x squared plus 4, and y equals x squared. Now, y equals x squared is your most basic parabola, right?
The parent function, right?
Yes, that is the parent function. Where does it start?
What do you mean, 0, 0?
Yeah, like where's the vertex? At 0, 0. Okay, so then you could go up and it just goes up, like not exponentially, but it just goes up, Anyways, now the x to the 4th one, you probably don't know that one. For the sake of time, we are just going to plug it in to the calculator. Like I said, you could just plot numbers until you eventually get a graph that fits in the parabola. This is one where I would graph the parabola first if I had to do it by hand, so something like this. So, I know that it would have a point here, 1, 2, so on and so forth, and I would do it. I would try to pull values inside my parabola here. So, I would plug in 0. At 0, I'm at 4. So, that's up here. Right? At 1, what do you get if you plug in 1? For this?
0.
1 minus...
Wait, 1. You just get 1.
Yeah, so at 1, it's at 1. How about at negative 1? Because since it's down over here, I know this is already hitting, so I just need to see what happens on this side. So what if I plug in negative 1? And so, obviously this graph is going to keep going, something other than that, but you can assume something along those lines in the area that I'm looking for is in here. Now, if you don't believe me, or maybe you do, but maybe you shouldn't yet until you see it for
I
yourself,
would not believe you.
Everybody,
plug these functions in individually here, and we'll show you that we're right.
Wait, you hit trace? Oh, I gotta zoom out.
First of all, you just need to type this in.
I did. I did.
And then Zoom 6
But I'm still. You did zoom 6.
for Zoom Standard. So notice what happens with this graph, right? If you watched it,
It looks funky.
it made like a W. This is like the middle of the W. So basically this would just keep going, but I don't care about any of that. I only care about this middle region here.
So your top one would be the y is x to the fourth minus 4x squared.
Yes, and this would be g of x. And this would be from -1 to 1. If you wanted to zoom box it and see it closer, now to go behind and check that these are truly right, somebody do the second trace intersect.
It's right.
Yeah.
It is from -1 to 1. So see, without even having my calculator, by knowing just simply one of them, I could find the whole thing. I don't care what happens to the graph outside of that region, right? I'm just trying to find area.
So you can
In here.
Like, so if you don't know like the formulas, you can just plug in numbers until it might take more time, but you can just plug in numbers till it intersects.
Yep.
Okay. So that works.
So that's why I'm kind of like showing you this now, because obviously normally I would just probably teach this by showing you on the calculator, but I don't know what they may or may not put on the no calculator portion, so I feel like it's good. Even if not for these problems, for something else, just by simply plugging in numbers, we can find the graph without having to do all that. So, integral from, whoa, not that. Integral from -1 to 1 of x to the fourth minus 4x squared plus 4 minus x squared dx. Now, before I integrate, what do you think I maybe should do?
Combine like terms.
Combine like terms. So -1 to 1 of x to the fourth minus 5x squared plus 4 dx.
Alright, so now we gotta integrate it. Of 1/5 x to the fifth. 5/3 minus 5/3 x to the third. Plus 4x.
Evaluated from -1 to 1. So if I plug in 1, I've got 1/5 minus 5/3 plus 4 minus, plugging in -1, I've got -1/5 plus 5/3 minus 4. All right, so then I've got, okay, 1/5 plus 1/5, so that's 2/5. -5/3 minus 5/3, so -10/3. And then 4 plus 4 is 8. So then everything over 15, 6 minus 50 plus, I don't even know what 8 times 15 is. We might be missing a part of this. 1 second. My calculator would cooperate. There we go. Okay. What do you notice about this?
That it's
It's symmetrical. Always supposed to be symmetrical.
it's
Right, but what's different about this graph compared to the other ones?
It
There's
stays on
multiple
top of it
intersections.
doesn't go negative.
There's multiple intersections. Yes. It also doesn't stay, I mean, it doesn't go negative. That is also true. But so far, I found this area.
Which one are those?
You gotta find an area like all three.
I haven't found this region or this region yet.
Which we need to do it one more time.
So yes, we need to do it again. And
So
then
that
we'll
was
have
just
to
like part
combine.
A or something.
Yeah, well, see, if I had actually paid attention to the graph originally, we probably could have just done it all in one fell swoop, but I was not thinking about that. So we need to figure out how to get from here to here. So we know it's something to -1,
Yeah.
right? So it's whatever this value is. So I need to know what this intersection point is here.
Go round and say like -2. Cause it's just about there.
That's probably fine. So -2 to -1.
oh, it's that easy.
I just yeah, I just did it.
I mean, because I'm guessing it's like 1.99 something ish. Yeah, just say -2. That's fine. I'm still gonna leave that box because that is part of it. But now let's see. We need to. I think we need to flip them though when we do this integral because the other graph is on top this time. X squared is on top this time. So the integral from -2 to -1 of, what was it, x squared minus, I'm going to go ahead and just do the whole thing, x to the 4th plus 4x squared minus 4. Negative x to the 4th plus 5x squared minus 4. So now what do I have when I integrate this?
Yeah, -1/5 x to the 5th plus 5/3 x to the 3rd minus 4x.
So plugging in -1, I'm going to get positive 1/5 minus 5/3 plus 4 minus, I'm going to bracket this off, a positive, oh goodness. 32/5 minus, what is that, 40/3 plus 8. So -31/5 plus 35/3 minus 4, I think. I'm just gonna plug these in because I can.
So do we have to get the other side?
Or can we assume that they're equal?
We're gonna assume that they're equal. So we actually could do 2 times this, and if we had wanted to, we could have done the right side and used from 1 to 2 instead of from.
My question is,
Negative
how
two,
would you go about it doing it in like one?
Well, it would have. We could have done it in one step, but have done like multiple integrals. We still would have done this, but we would have had this integral plus the integral that we had already solved for up here. Like that would have been what we would have had. So it would have just been done in pieces.
So then do we add the 76?
Yeah, so to get the total, we're going to multiply this by 2. So the total area is going to be the 76 over 15 plus 22 over 15 plus 22 over 15. Which ends up being 8.
All of that was.
Now, obviously, when we started out with the area, I just had you graph that part. If I had you keep going, we would have realized that it was going to intersect again, and that's what would have led us to that. But I just was like, oh, it's just going to intersect once, because all the other ones we've done have only intersected once.
Yeah.
Is
But-
it hot in here?
I think it's a little warm, yeah. We'll probably do like 2 or 3 more tomorrow, and then we'll be done with this stuff.
Are we looking at a quiz?
Probably.
For these 2 sections?
Probably, yeah. I have to see. Let me look and see what 8.3 is. Yeah, because 8.3 goes into volume, so probably after this, and then 8.3 and 8.5. We don't have to do 8.4, I think,
Okay.
and then we'll be done.